I want to go over how to use the table to go from a probability, back to values. And I'm going to do 21B here with the Navy pilots. I've done this I have videos up on both Excel and the TI. It is easier, it's one-stop shopping, but I think the hands-on table can be a lot more understandable, and I think that it can feel a lot more like you actually kind of understand what's going on. So it's really up to you what you decide, but I want to make sure you have all the options possible. Okay, so always start with the picture, okay? No matter what method you're doing, and you'll see I drew the same picture for all of these. So I want the bottom 3% and the top 3% excluded. So I need to figure out what values here are at the cutoffs. To do this, I'm going to first have to look up what the z-score is and then take that z-score and convert it back to this distribution because I have a non-standard distribution here. So I'm going to find the z-score and then I'm going to convert each of these back. So here at the bottom three, so I'm going to open up the table here. Okay, so I need to find 0.03. Okay. So I'm going to look for the closest in the body here in the middle. I'm looking for the one closest to 0.03. And I can see, no, that's 0.003. Hold on a second. I want 0.3. 0.3. 87. Okay, right here. There's the closest. Okay, 301. And you're just looking for the absolute close one. So I can see this tracks back to negative 1.88. Okay, so this is negative 1.88. Now I need to look up, because remember this goes to the left. And this is what's also nice about the table, is it shows us up here that it goes to the left. So I need the left value for this, which is all but 3%. So 0.97. So I'm going to come down here and I'm going to look for 0.97. I want the closest one to 97 right here. You'll notice here this is 1.88. This is symmetric, guys. Remember, this is symmetric. I could have told you that was the answer before I actually did it. The reason I could do that is because I know it's symmetric. So these values have to match. One's negative, one's positive. So once you look up the other, you could actually just write down the other one changing the sign. So just a heads up on that. Now, this isn't the answer though. These are the z-scores. I need to convert back using this formula up here. This is our conversion formula to the x value. So down here, negative 1.88 equals, I don't know what x is. My mean was 63.7. and my standard deviation was 2.9. So now I need to solve this equation right here. So I'm going to do that here by, let's see here, I'm going to start by timesing both sides by 2.9. So let me see here. So 1.88 times 2.9 is negative. That's not what I put into my calculator. Really not what I put into my calculator. Okay, negative 5.452 equals x plus 63.7. I'm going to subtract. Okay, right there. This is a minus. I'm like, no, we should not be negative. Heights are not negative. Plus 63.7. So plus 63.7. Okay, so this is 58.2 equals x. So this is the first value. So this value is 58.2 when converted back to the distribution it's part of. Now I'm going to do the same thing, okay? But I'm going to do it for, I'm going to try to get it to behave here. It's not going to. I'm going to do the same thing, but I'm going to do it now with the other ones. So I'm going to do 1.88 equals, so my positive, minus, it's still the same, 63.7 and 2.9. So 1.88 times 2.9. It's not what I put into my calculator. Okay, so 5.452. This is the same value, right? It makes sense here. And then I'm going to add 63.7. You could kind of do this together if you wanted, because you can see a lot. And then so this is 69.152 equals x, or 69.1 or 2, depending on how you round here. That is my top value. So you can see here a little bit more steps to it, but I like the hands-on nature of the table, and my favorite feature of the table right here is the picture, because I think this picture really helps you remember which way it's going, so you know when you have to do things like subtract from 1. So that can be very helpful.